kind of screwing up in a lot of ways. That's my experience. That's a lot of my colleagues' experience. So I think that could be kind of our collective experience. So there's that. Oh, one more thing, you may be hearing some noise in my background. And so I have a 4-year-old who is kind of with dad while his sisters and my wife are out of town. So he's going to be running around watching Mickey and making all kinds of noise. That may be the situation for many others. So please feel free to jump out, run away, or otherwise this is being recorded. It's going to be posted. So that way people can kind of pick up where they need to. I will periodically have to ask him to stop yelling. But such is the nature of parenting for those who are in that kind of stage of life. All right, so with that, we are going to go ahead and get started. You know, one of the things I'm really grateful for everyone having done, I kind of put on one of the tabs was just like this get to know you thing to get a sense for what is it that everybody wants to potentially try to get better at. And I think the 3 salient things that kind of came across to me were data management, data analysis, and data visualization. And so I think that those are the kind of 3 movements that I'd like to take us through and kind of work through together this summer. So today is really kind of oriented towards an overview of R just in terms of the interface. I think there were a lot of folks who kind of step into R and they kind of jump into it as just any programming language and just start coding. And at least maybe that's me projecting, but I know that was my experience of starting to jump in and try to do some things, but didn't really take the time to kind of understand simple things like, well, what are these different windows? What are ways to kind of be able to understand errors, different color codes within this? What's the best way to get packages loaded? And just gain familiarity with the interface. So this is kind of like an interface and an unpacking of things that will really, I think, benefit us for the rest of the summer. So if you're a person who is proficient in opening R and sees the windows and says, yeah, I got this, this is gonna kind of be old hat to you, to use like a 1940s term, I guess, and that's just what I'm doing. Nope, don't climb on that, climb down. So today's going to kind of be getting a little bit familiar with R as a package in RStudio. And then the rest of June is going to kind of be focused on data management. July, I think, focusing on data analyses, and August data visualization. So I think a lot of the data management will be through using the Tidyverse package. So if folks want to be thinking about whether on your own time installing that, tinkering with it, I think that's going to be the primary data management tool that we'll use. All right, so I think those are kind of all the notes. So we'll kind of go ahead and jump in. So what's actually really great is that when I was looking at some of the comments this morning, someone was actually asking about downloading R and where they could download R. And someone was very helpful in terms of posting where they can get that. And you can go to, if you Google R, usually the first thing that comes up is the rproject.org. And the reason I'm really glad someone asked that question is that I think it's important to kind of disentangle, for those who aren't aware, there is a difference between R and RStudio. And so this right here is actually R. And there's a very minimalist view of it. You kind of have a console window where you can type in things, I don't know, 2 + 2, right? So you could type things in there, but you don't get kind of like a comprehensive interface to be able to look at what you're coding, where are your data, the different packages, the figures. They come up in different ancillary windows, but it's not very user friendly. And so to actually make R maybe more functional and flexible for learning purposes, it's going to be really helpful to have R and RStudio. And so you're going to want to download both R and RStudio. And so if you don't have that, I would encourage you to go ahead and download those things as I'm starting to walk through some of these introductory kind of pieces related to the software. Oh, even just for fun, like one of the things I love about R is like it can do just tons of really fun things. So there's this great package called Cowsay, and you can actually just run this and it gives you like a cat fact. Of course, the one thing I would do would be something about like sexually active feral cats. I mean, let's do another cat fact. All right, there we go. So, I mean, it does something kind of cutesy and fun like this. For those who are kind of XKCD fans of the comic, there's actually a package that will pull the comic, and you can choose a current comic, and it will produce over in this window over here what the current comic is, which is really fun. You can also do things where R can interface with web pages like Wikipedia. And so this is, for example, if you wanted to know something about like popular cat names, you can put in kind of like the website, and then just through a different set of code, you can create all these objects and then ultimately say like what were famous names in 2010. So yes, you could go to Wikipedia and just get the top cat names in 2010 and find it. But you could also code it if you wanted to. So there's just lots of fun stuff. I like to, in some of my classes, show how you can build different Star Wars memes through R. I will not be boring you with that today. So real quick, kind of getting back to this idea of R and RStudio, it's kind of thinking about like a car and an engine. And so the engine that really undergirds this is going to be R. But the car itself, right, the way you kind of interface with the engine is through the car dashboard itself. And so RStudio is going to be that interface. So it's probably helpful for us to start looking at the different windows that we actually work with. So if you have your window open, you're kind of following this, you can see that there are 4 different panes with lots of tabs in each, and it's pretty easy to get overwhelmed by it. So we're going to just kind of start with each of these. One is this right here is this is kind of your code editor in the upper left. And so this is where the majority of your time tends to be spent, of where you can write out your code, you can mark your code, you can run chunks of your code to see if it's working or not. And so this is typically where all of the code is going to be stored for processing. Down here is it's the console. And so the console is actually where the results of what you run tend to spit out. And so you can see when I was running the original code, it would, whatever I would highlight and run, it would then appear down in the console. And so these are places where you can see whether the code ran correctly or not. It will give you results in this area. It will give you warnings. It will give you errors, which I'll talk about in a minute or two. But this is, I think these 2 screens on the left are where you're going to spend a lot of time if you're not already familiar. So again, up here is where your code will tend to be stored. Down here will be after you've selected your code and run it, you will see whether the code was kind of executed correctly, and then what the result of your code was. So whether it's something as simple as creating an object or a data set, doing very basic mathematical operations like the 2 + 3, or running simulations, a lot of the processing and result of that will show up in the console window. And the bottom right over here, this is where you tend to have the most tabs. So you can see that there's files, plots, packages, help, zoom, a viewer. And so the files, it shows kind of the file and the folder structure for your current working directory. So wherever you are doing work, and I'll talk about a working directory in a few minutes, the files that are part of that working directory are going to populate here. That would be similar to like if you go to My Computer on a PC, or if you open the Finder on a Mac. This is showing the results of where you are right now, where R is pointed right now in that same way. The plot and viewer is where you will see plots and you can view them. And so the viewer tends to be a little bit more for kind of HTML files that are created from things like R Markdown and knit. Plots is where you'll tend to see most kind of graphs and things of that nature. Packages is where you will be able to see all the different packages that are both inherent to default R. So when you first install and bring up R, you're going to see a number of packages that exist there. And you can add to all of those at any time. And so you can see that I have a very long list of packages here, all used for all different kinds of purposes. So this is where you'll be able to track what you have. You can update what you have. You can get a description of what the packages are. They give you version information. And you can see here as I'm hovering, You can also remove a package just by clicking on this. And then help is a really great function that lets you be able to, if you're working through a particular package and you have a particular function that you're trying to run or a particular analysis you're trying to do, and you're getting kind of screwed up on the code, or you're not sure what step to take next, you can do a broad search through our documentation for the different packages that you have on your within R. So it's a really nice and flexible way to be able to get some quick information about both what your code is supposed to look like, and it also gives some really nice examples of what your code could look like. So here you see a very broad structure. This is under the this is for like the MERT package. It does multi-dimensional item response theory, and so this tells you that if I wanted to get the area, if I wanted to look at information functions, it kind of gives the broad structure of what the command is supposed to look like. And then it tells you what each of these different components of the function look like. So theta lim kind of tells you what the range of integration points would be that you want to specify. So it kind of gives you the different arguments of the function, the different values of it, and then it actually gives examples. And so you'll tend to find that for many, if not most packages, they'll have examples of what things should look like. So it's a really good kind of self-tutorial. I tend to use this a lot in conjunction with just Google. Google is wonderful. I think everyone knows that. And what's even better is when you follow, whether it's, you know, Hadley, Allison, or others who are very proficient R folks, they will very quickly admit that they are all over Google for all kinds of R stuff. Just because it's open source, it's so expansive. There's so much you could do. It's, you know, there's a very broad community that's willing to help and provide answers to questions. Stack Exchange is very robust. If you don't already use that, that's a great place where people kind of contribute and crowdsource kind of answers to complex issues that come up with R. So that's this window down here. And then up here is the environment window. I'm going to shrink that down a little bit. And so the environment window allows you to be able to see the different data sets or objects that you've created. So anytime you create a new data set or read in a data set, it will populate here. And what's nice about it is that you can see that there's the little arrows here. If you kind of click on those arrows, it's going to tell you what's inside of those data sets. This is awesome. People are already posting all kinds of information. So yeah, please keep doing that. And actually, one of the things that is in our team is I created like a little notes page. And so if people are so inclined, I think like on the week 1 tab, there's something called notes. So as people are hearing me say things and they're like, no fam, there's a better way to do this. Please post that there, because I think this is really for all of us. This is, as I said, this is, you know, I'm not the wisest person with these things. So as people hear me speaking, like I know something better or different, please post that in the notes page, because this is a community resource. So for those who know more, please put it there. Sorry, I'm like tracking what people are saying and talking, which is never the smartest thing for me to do. All right, so that's a little bit about just this environment right here. So I think it's helpful to, you know, walk through the code editor, the console, the environment, the files, which we've just done. But I also think it's useful to kind of look at the menu bar, because it can be easy to just start getting a familiarity with each of these panes and then start doing coding without recognizing that there are some important components up here that are going to be useful to you in your coding. So one is that when you open RStudio, it's going to give you kind of a coding window, but you may want to be able to create a new script, or you may want to create a notebook. You may want to start a new Shiny app. There's all kinds of functionality that you can be able to include here. So going to a new file will allow you to be able to open up another coding window. And so if you were working, let's say within one folder on a certain project, and but then maybe you're like me and you have ADHD and you need to switch gears to work on another project, you just open up another coding window and you can start developing code for that project, saving each file to its appropriate directory. So that new file will allow you to be able to have, almost like in Google, you can have all of your different windows open for different things you're thinking about. Within RStudio, you can have, you know, 30, 40, 50 different windows of code open at any given time. I would not recommend that, but you can. Um, Another useful tool here is importing data. And so if you go to a file and import data, this is a way, and I'll show this in a little bit, is there's different way to bring data in. And so what's nice is that as you're getting your feet wet with R, if you're not wanting to immediately start with code on the side of reading in your data, you just want to start using your data, you can actually just use this function where you go to File, Import Data, choose the type of data file that you want to read into R, like SPSS, and then if you click on that, it's going to bring up something like this. And so all you do here is what's similar to any other kind of data analytic file, right? You find the file, you select the file. Let me see if I can find an SPSS file real quick. Yeah, there we go. So if I just choose something like this, and of course I'm choosing a ginormous file, so I'm just going to go ahead and cancel that because it's in the cloud right now. So what will happen is the file will populate, and you can just click import, and then you can, that file will become an object. The other thing you could do is you can see down here is that it's giving you a preview of the code that it's actually using to be able to access the data and read in the data. So you could just identify the file and click import, or you could copy this data and then kind of put it into something like this, right? And so Haven is the package that reads in an SPSS file. So if I had that, data file name, it would just be datafile.sav. And then it's creating a new file called dataset, and that dataset is a function of what you're reading in. So you can either code it, or you can automatically import it through that graphical kind of user interface through the file import. Let's see, file and projects. Oh, so one thing I'm not going to be talking about right now, but is probably for those of you who want to be able to think about easily passing along your code, your data, and the results you've been working through, you can actually treat each of your projects as a true project. So rather than having 30 individual files of code open in Windows here, you can actually do something where you create a new project. And what the project does is you point it to a directory. So let me see if I can bring an example up here. Yes, let's save that. So what you'll see is I'm opening up, this is actually an old project, and it's kind of closing out the other thing that I was working on. And so a project is kind of stored within a particular folder where you may have kind of code and data sets and all kinds of things, all that are automatically stored within a workspace. So what you can see here is not only has the code changed, right? Like I have all of this code that's here. I have this other set of code that's here, and still other, an untitled code that's right here. And I also have all this data that just already populated that wasn't there where we just were. So a project lets you to be able to store a massive amount of things that you're working on within a current project. So for example, this is psychometric work I'm doing for a project that's called Project Matters. And so I have all of this code, all of these data sets that I created. I don't want to have to recreate them. So by keeping them in a project and by saving the project, I don't have to rerun code every single time. So it's actually, my son's very excited about that for me. So you can actually do that. Sorry, people are texting about, I think, the chat function. I see people are asking about not being able to hit the chat function. I can try to take a look at that at the end of this. So projects are actually really helpful if you're going to be doing lots of work, lots of data management, data analysis, creating subsets of data. Using things in a project makes it so that way you don't have to rerun and recreate all those data sets all over again, right? So like in SPSS, or in SAS, a lot of, like, I don't know how SAS has changed, but if you wanted to create new files, right, you can either create brand new files or temporary files. But then when you want to use them again, you have to access them and kind of use the lib name and read those in again. You don't have to do that with a project. They're all kind of automatically loaded when you load the project, which is really nice. All right. So two more things that are going to be helpful. One is session. And so I like session for when things tend to blow up. So if things get stuck, you can kind of terminate the session. You can restart R if things are kind of taking too long, or you want to be able to just start a new workspace. I think those are two things that are going to be useful to you. You can clear your workspace, which is actually going to be really helpful. If you continue to run lots of models, then kind of the stored memory can actually bog down and prohibit you from running new things. That's like minor stuff, but those are just good things to kind of know about, where it's like, it seems like things have stalled, things aren't working too well, what should I do? You can either try restarting R or terminating R, and those tend to be things that are helpful to me. Others who might think about like workspace stuff or quitting, please feel free to comment on your experience with that. And then the last thing I will touch base quickly on is just aspects of the options. This is something that I use quite a bit. So if you go to Tools and then Global Options, this allows you to do a lot of things. So one is you can actually change the version of R that you want to access. So this is kind of getting into the weeds as opposed to staying 60,000 feet. But a lot of times packages may only be written to work in certain versions of R. So whenever you upgrade R, like right now it's 4.0, there are lots of packages that can't be run in version 4.0. They can only be run in 3.5.3 or 3.0 or otherwise. And so you may find over time that you may install a package, do a particular kind of analysis, forget about that analysis for a period of time, upgrade R, try to run that analysis, and then it doesn't work. It may say this package doesn't run in this current version. So what you have to do is load up an older version of R, and that's what you do here. If you want to change to an older version, you can just click on change. You can click the version that you want to run, and then you click OK. You'll have to restart R. But this is the mechanism by which you can be able to, for highly specialized packages, at times, this is a really useful function. There are certain things that I run that only use 3.0.2, and that's because those packages aren't being updated anymore. They were written, published, and then there's no more support, so they don't work with newer versions. So that's one thing that helps. This is another one, and maybe this is because I'm old. I'm like 41, so like, my age is 41, but like my eyesight, I'm 140% years old. And so, Zoom is actually a nice function. You can change that. You can change the font size and the style and the theme. So you can do a lot of different things. They don't have Comic Sans, so that's kind of a bummer. So I think those are useful things, for aesthetics that are good for me. Here's the pane layout, right? So you can do a lot of manipulation of stuff to make it usable and useful for you. So if you're ever situated in kind of the main screen and you're trying to think, I wish I could increase the font size, I wish I could move these panes around, I wish I could add this other thing, it's kind of going to Tools and Global Options. That will let you take care of a lot of that kind of stuff. All right. Sip of water. Teddy, you doing okay? You doing okay? Okay. You want water? Okay.
Okay.
Okay, here you go. Here's your water. All right, so I thought it would be useful to kind of talk about some things related to starting to actually use R, right? This is all like high level stuff. What about actually kind of getting into the weeds on this just a little bit? Whenever you start writing code and then wanting to run code, there are two different ways you can actually get your code to run. One is if I want to do something very simple, just like 2 + 3, you can highlight it and hit run, right? And so you can see I highlight it, hit run, and then down here it shows the code that was run, and then it shows what the result of that was. And so 2 + 3 = 5, yay. The other thing you can do is you can just have the cursor on the line of code that you want. If you're using kind of a PC, sorry Max, I don't know what you do. It might be the flower. Is it a flower or an apple? I don't know what's on a Mac, but If you have the cursor on the line of code you want to run and you hold Control and hit Enter, it will automatically run that line of code. And not only will it do that, it will Command plus Enter for a Mac. Thank you. Is it Lauren that said that? That's awesome. Thank you. So if you do Control Enter, it will run the code. You'll get the result, and it moves the cursor to the next line. So if you just wanted to run a whole bunch of code, you could just kind of go through and do that. If you wanted to run a whole block of code without doing Control Enter, you can just you can highlight it and hit Run, and then it's going to give you a whole result, which is very nice. All right, what's actually really important as you start getting into beyond just basic arithmetic stuff, because no one is doing R just for the basics. We're going to be thinking about complex analyses, data viz. An important aspect is thinking about how you actually frame up some of your arithmetic operations. I'm in stats, not math, so you would think I would know words, right? So so we can do 2 plus 3, and we can run that, and that's okay, right? We get a result. But if I was to say 2 plus 3 equals 5, I'm going to get an error. But if I do this, 2 plus 3, right, equals 5. Now I don't get a result. But if I do 2 plus 3 and then a double equals 5, I add arithmetic. Thank you, Rick. I can always count on you to correct me. I appreciate you. And so depending on how you define your code, you're going to get very different results. And so the reason that I get an error here, I get nothing on this type of code, and then I get something like true, is that each of these things is doing something different. And I'll explain what that means. One is that if you're wanting to actually use an equal sign, you actually need to use a double equals. And so a double equals in R is kind of testing for an equality, right? It's not, in this case, you're not actually saying 2 plus 3 equals 5. If I run that, it's going to give you the result. If I run this, what it's actually, Teddy, dude, don't burp like that, buddy. Oh, okay, you're done. Yeah. What it's trying to do, so what this is doing, it's looking at a logical expression. It's trying to say, does 2 plus 3 equal 5? So when I run 2 plus 3 double equal 5, it's going to return a true if it's true, right? Does 2 plus 3 equal 5? True. If it's 2 plus 3 double equals 4, false, right? So it's on the back end doing the math, but then it's returning kind of like a logical result as to whether it's true or false. I guess that's Boolean and not logical operator. So that's what's happening here, and why we don't get a 5 when we run this is because it's verifying whether what's on the left it has the right relation to what's on the right-hand side. So in this case, 2 plus 3 does equal 5, so it returns a true. Here, what R thinks I'm doing is trying to create a data set that is called 2 plus 3. And so within R, a single equal sign is assigning a value or a set of values from the right-hand side of the equal sign to what's on the left-hand side of the equal sign. So what R is reading is essentially saying, create a new data set called, or create an object called 2 plus 3. And within that object, store a value of 5. So when I run this, it's not returning any value. It's simply satisfying the command. And what you can see up here is that it's actually storing in this environment the 2 plus 3 data set and the value that's listed there, right? So that's telling us that it's stored. And if I wanted to actually see what is in 2 plus 3, right? If it's treating it like a list or a data set, and the value that's in there is supposed to be 5, if I copy this and run it, you can now see that a value of 5 is there. Again, it thinks that I'm wanting to say, create a new data set called 2 plus 3, and in that data set, put a value of 5 in there. So this two-step procedure would actually give me the value of 5 because it's first creating it, And then second, it's producing what's in that data set. All right, I hope that's clear. If things are unclear, just post in the chat, and either I'll try to answer those towards the end, or I think there are people who are clearly being helpful and yay team on this, and so folks can help out as they're willing and able. All right, so that's a little bit on kind of the relation between what is in the kind of code window and what produces in the console. So if we do just basic math, we can run that very quickly and it will run in the console. But when we start kind of setting up expressions, we need to be very careful about how we define those expressions, because it will either try to, in this case, it was wanting to create an object, right? So this is the object 2 plus 3. The reason this returned an error, right? It's saying the target of assignment expands to a non-language object, which in layman's terms is saying, you are trying to create this kind of object. You're trying to create something that stored a value of 5, but you are actually using non-language. You are using numbers and symbols like this. And so R does not want you to use something like that to create an object. And so that's why it's returning an error, which is why if I pivot to just using letters, it's totally fine to do that. Now I could do 2 plus 3, 23 equals 5, and that's okay, right? It's just that you can't have numbers only with these operands in it. So I get kind of the same result. So, all right, so moving a little bit into variable types that you're going to encounter when we start looking at data sets. So there are characters, right? And those are things that are in single or double quotes. So you can have characters in your data file. You can have integers. You can have numerical values and so the difference between integers and numeric in R is that numeric encompasses things that have fractions. And so you can have decimals and fractions, whereas integers are just kind of the whole numbers. So numeric tends to be kind of like a broader categorization. And then and integers are a little bit, those tend to be the whole numbers. Factors are categorical variables where each level is a category, and those levels can be represented as characters or as integers. I tend to use integers for things like sex or gender or race, ethnicity, or otherwise. I tend to express those as integer or as factors because then as integers, because then it's easier analytically, I find, than for characters. Let's see. You can change among variable types, and I think I've got an example of that down below. So by the way, one of the just like shortcuts that you can use. So whenever you're wanting to have a set of, you want to annotate your code, you can see that I'm using the hash. So hashing is a way to be able to have words that I'm saying not be part of my analysis. So hashtags let you do that, but it can be a pain to start every single row with a hashtag, right? I don't want to have to do that. And so in PC, all you have to do is just highlight it, and then if you do Control, Shift, and C, it will take that entire block and it will put that hashtag in front of it. And so if someone's able to kind of put maybe what it is on a Mac, I'm sure my Mac friends would be grateful for that. So Control, Shift, C is a way that you can just type and then at the end of it, select it, and then be able to just use it as annotated. It looks like someone is saying that's the same in a Mac. So that's great. That's good to know. So that's a little bit about variable types: character, integer, numeric, factor, etc. Let's see, I talked a little bit about objects, right? So objects are where values are saved in R. It's like a data set. A data frame, it's a rectangular data sheet, and that's where it gets into a little bit more complex things that as we get deeper into the summer, I think it'll make a little bit more sense, because there are differences among kind of objects that are stored as frames or as matrices, or matrices that are independent of objects. There's lots of different aspects of ways things are titled and used within R. In general, we'll be dealing mostly with kind of like objects, frames, and then lists. Lists are where you can have this object that has multiple things stored in it. So I'm sorry, 1 second. Teddy, do you need to go potty? Are you sure? No potty? Okay. Sorry, everybody. All right. So objects, frames, lists, matrices. This is going to become pretty common language as we work through the summer, and you can explore that on your own in terms of what some of those specific differences are. But I'll kind of show an example of that a little bit. What's going to be helpful as well is we'll probably work with vectors a little bit. So vectors are a collection of elements that are of the same class, and so a vector can be defined this way, where it's like a C, which means kind of combine or concatenate, and then you have a sequence of things that are stored inside that vector. So for example, here I can create a vector of 1, 2, 3, 4, and so if I run that, you can see 1, 2, 3, 4. I think I can also do C1:4, and it does the same thing, right? So if I do 1:4, it's sequencing it from 1 to 4, or 1 to 10, or 1 to 100. You can also do character values in here. So if I put in something like Jordan, LeBron, Wilt, Russell. Right, so now I'm getting the list of the greatest. Don't at me on that. I mean, you can if you want, but I have feelings. So there's different, you can put all of these different things into a vector, and then you can use that vector to be able to either merge it with other vectors. You can use it for analyses. This becomes really important the deeper you get into R for like matrix kinds of stuff, like creating vectors is becomes pretty critical. So what you can see below, and it already ran, is that a vector will just produce the number. But if I were to say produce the vector as a matrix, or store the vector as a matrix, then you actually get it as a matrix, right? And so I've listed out 1 to 4, and so it's assuming that there is one column with 4 rows, and then the rows are 1, 2, 3, 4. And so there's all kinds of different ways to define your matrices. But again, it just speaks to when we're kind of screwing up in R, a big part of it is just going to be due to how we've defined something. And so if something is numeric, but it wants to be integer, you can change it from numeric to integer. And again, I think I'm going to show that in a minute. If you want a numeric value to actually be character, you can change those kinds of things as well. No, don't climb on that. All right, good job. Here, sit over here by Daddy. Here, sit right there. Yeah, good job. All right. Let's see. Oh yeah, just a few more things. When you are kind of creating objects and defining elements that go into objects, an equal sign, and then kind of the arrow, which is the less than the dash, these two can basically be used interchangeably. So if I wanted to create, let's see if I'm right, NBA tops equals this, right? So now I've created an object called NBA tops, which has, it's storing these 4 values, and then I produce it. I should get the same thing using an equals as if I kind of use that, right? So it produces the exact same thing. And so I don't know if there are people who are wiser and more proficient that know why there are 2, and if there is a specific reason to have 2. I know that part of it is it's level of assignment. So when you do this, you're saying assign this vector to the left, which is NBA tops. I think, and let's find out if I'm right. I've never actually tried this before, so because I'd never really thought about it before. So if I do this, no. I want to do. Yeah, it's really a which way you're assigning the aspects of which way you want to assign the components or the variable that would go in your data set if you want to assign it to the left or the right. So it's why I pretty much always just use equal signs, because I'm not a data scientist. So maybe in kind of broader, whether it's data science or epidemiology or programming or Python or of all the many kinds of things that R can do, it may make sense to kind of do what I just showed of assigning it to the right. Nothing I've ever done is actually useful assigning to the right. I always assign to the left. And so if I'm assigning to the left, it's easier for me just in my kind of my brain, for better or for worse, just to use the equal sign, because that's how, it's helpful for me to think about, this is defined by this other thing. All right. So I personally just like that. Okay, so yeah, here's an example of just a little bit more of using kind of like operands of like those two things are the same. Plus, minus, times, divided by, those are all the same. Equals is going to be double equals. And so if you're wanting to define an expression based on two values or two things equaling another, you need to use the double equals and not the single, because it's going to think you're trying to assign something when you use a single equals, right? So this wants to assign this vector to this object. Let's see what happens here, right? So, oh, true. See, R by default agrees with my lists. That's not what it's doing, right? What it's actually saying is, I previously said NBA tops should have these 4 values in them. So by saying, does NBA tops as an object equal a vector of these 4 things, it's why it's saying true, because the 4 pieces, the 4 things that are in NBA tops, right? NBA tops. Jordan, LeBron, Wilt, and Russell are in NBA tops. And so this matches Jordan, LeBron, Wilt, and Russell. So that's why I'm getting 4 values, right? The first position is Jordan here and in NBA tops. The second is LeBron. Third is Wilt. Fourth is Russell. And just that, not Russell Westbrook. If anyone was thinking I was saying Russell Westbrook, you should probably just leave. Please don't leave. But not Russell Westbrook. I just wanted to make sure people were not thinking I was thinking that. All right, so so what I can do here is I can create an object that's called A, and in that object is 2 plus 3, right? And so so it produces 5. I can also do B with assign 2 plus 3 to B, and I get the same result in both. If I wanted to know, right? I talked about the different kind of variable types, character, integer, numeric, etc. If I kind of create this object of A, I wanted to know what is the class of A. It's numeric, right? So it's telling me that A is a numeric object. But I could change it, right? I could change that. I could change the result that's stored in A to be something different. So when I was saying before, you can change, you can kind of make a numeric value character. I can do that by saying, A equals as character. And if I do that, right, I've now changed the nature of A to go from numeric to now be character. And then I can do the flip of that. If I've got my object called C and it contains the value, 10, but it's a character, right? That's why it's in quotes. So I had quotes here. It's producing in quotes. It's not reading it as a number. It's reading it as a character. I can identify it as character, but then I can switch it to numeric by saying as numeric. Go. All right. So that's some light overview. We've got about 15 minutes left, so I think this is where we're going to get into some stuff. So one thing that will be helpful is thinking about some of the basics. It gets into like packages. When you start a new session, what should you do? Part of it is finding out where you are right now. So if you were to write out, get WD with an open and closed parenthesis, what that's saying is get your current working directory. It's basically when you open R, what folder are you working in, right? So right now, it's saying that I'm in users YMP documents, which is basically just right here for me. So if everyone were to type, get WD with an open and closed parenthesis, everyone will be getting something different than this, because everyone is in some directory based on where R exists on your computer. But because you're not going to want to do your analyses, it's likely that your data sets are in just all kinds of different folders, right? So whether they're in Dropbox, or you just have a list of wherever your projects are, you basically want to set your working directory to where you want to work. So for example, if I go into this folder and I say, oh, this is where I want to do, this is where my data sets are, and this is where I ultimately want to do my work, I can go up here on a PC and be able to kind of copy the directory for where I want to work. And then I can type, set WD. You can do set working directory. And then here you can paste the directory. Now there's two things when you do this. One is you need to put this in quotes. And so you could either put the quote in, put one at the end, one at the beginning. The easiest way I found is you just highlight it. And then I just kind of do shift to get the quotation marks, and it automatically puts it on the boundary of what I've highlighted. The other is that you have to move it from a forward slash to a backslash. R will not, like if I do this, right? So you're going to get this error because it uses, I think, the forward slash for some other kind of thing that I've never bothered looking into. All I know is it produces that error. And so you have to switch these to backslashes. So you can do that one of two ways, right? You can either just go through that manually. That's one way to do it. The other is you can, if you highlight the text and you do Control F in a PC, that's going to bring up now this little box right here. And in the find, I can put in the forward slash, and then under replace, I can hit backslash. And what you'll see is that the in selection box is check marked. And so so if you wanted to do a replace all, make sure that the in selection box is check marked, because otherwise you will run into what I have many a time when I first started using R, which is it just replaced all of the forward slashes with backslashes. So I just want to do it in this section. And now I can hit off. You can see right there, it said, everything was done. It tells you the number of times it did it. You want more water?
Yes.
Oh, good job saying yes. Whoops. There you go. Say thank you. Good. All right. So that's one error. Another is if I wanted to try to set my working directory here, right? Sometimes you may get something that says cannot change working directory. One of the reasons for that is that, oh, thank you, Andreas. So it was backslash is what gets put in, and you have to put in a forward slash. I apologize. So this is backslash, this is forward slash, and R requires forward slash. So it's, this is why it's called failing at R, because I fail at oral production and my communication. All right, so one of the reasons that you can get this error is that folder does not actually exist. So a lot of times you may not, maybe don't freak out about whether you have the slashes right or the quotations right. You may just want to double check as to whether you have put the right directory there. And so this does not, in fact, exist as a folder, but something like this does. So when you don't get an error, you can actually see that the, it just runs. All right. Oh yeah. So just kind of like a quick note about errors, warnings, and messages, because those are three different things you tend to get in these kinds of things. So errors those are red, and that's a legit error, right? That's prefaced with what you'll see is like error colon or error in, and it tries to explain what's wrong. Typically the code, like when you're running longer code, it's not going to run, like it'll basically just show up as if it ran, but there won't be a result. All right, Teddy. It will just say error in what you tried to do. So in this case, it said it can't change the working directory. And so you can that's one of the diagnoses. Other times, you just have to try to Google it and figure that out. So those are errors. Warnings. Warnings will also be kind of in red text, and those are prefaced with like a warning and a colon. R will also try to say what's wrong with it. So sometimes or actually a lot of times your code will still run. It's more of a caveat. So for those who have used like SAS, I'm trying to think about Stata or SPSS. Like I came from a SAS world where like if you were running multi-level models and there were not, you were specifying multiple random effects and it wouldn't, you had like a Hessian matrix issue, the model would run and it would give you a result. It would just tell you, that the Hessian matrix did not converge to a solution. So you can get warnings with results. It's still something you need to look to as a diagnostic as to whether your results are useful for their intended purpose, or whether it's yeah, I knew I was going to get that error or that warning. It's okay that I got that warning. That's just where you have to understand the analysis, the the data viz, whatever you were trying to do. You just need to kind of know why you got that warning, or again, you just Google it. And then the third kind of message you get is just a message like, yay, R does want to be nice to us. And so sometimes we just get a friendly message where it tells us the result of something. So yeah, so if it's red and it's an error, like that's kind of like a traffic light, right? Like you want to stop. It's a red light. If you get a warning, that's more like a yellow light. It's like kind of proceed with caution, but be aware of something. And if it's green, it's like, yay, you're doing great, way to go, woohoo. All right, so we're almost at time. What the rest of this is doing, here's what I'll do. I'm gonna take about like 10 minutes to just go through kind of reading in data, because after the data read in, that's where I'm starting to get into like I was just showing things like descriptive statistics, correlations, and just the importance of how you treat some missing data-ish kind of stuff. And so we will pick that up next week. Or again, you can do this on your own time and we'll still cover it next week because there were people who didn't come in this week that are going to jump in. So let me just cover for a few minutes about the beginnings of data import, and then we'll save exploration. So there are kind of two ways. There's probably a lot more that others may show. One is you can use that import function. So if you have SPSS, SAS, a text file, Stata file, you can use this as a way to read in your data, or you can read it in through code. So I'll do, for example, these are the data sets that were up on the page today. They're there that you can use. So one is an Excel file. And so I'm going to browse and go to there. I'm in failing at R. And right, so you can see that it's doing all the work for me right here. It's giving you a preview. Just so people know, this is HSB. For those who are in education research, this is the high school and beyond data. And so I could copy this code and paste it, or I can hit import. But what it's doing is it's calling the read Excel package, and then it's saying create a data set, an object called HSB, and it's reading an Excel file, right? Read _ Excel. So it's saying read the Excel file that is stored here, and it's called hsb.xlsx, and then it will view the data. So I can import that. It's going to view, and then I can automatically see it. So I could have copied the library Haven code or directly import it. I personally tend to just use CSV files. That's because of like a lot of people that I work with use CSV, and when they're exporting data from other sources, that's just easily transferable, and it's very easy to read in. So if I have there's the HSB version of that data. So if I just do read, yeah, it's because I didn't, I need to assign the directory. I need to assign set WD. See, in selection didn't come up, so I'm going to select it again. and then doing selection, there. All right. And so now I'm going to read in the CSV data, which is I'm just creating this HSB, read a CSV file that's called hsb.csv. And then I can view the data. So here's what's actually also really great about R is that if you spotted something that looks wrong in the data, you don't need to go all the way back to your CSV file that's in your folder, make the correction, and then deal with it if it's a very small thing. This code right here is basically saying create a new object called an edited HSB data, and it's using the edit command. So what happens is if I just ran this, let me do it so it actually makes more sense. If I wanted to edit the data because I saw something that looked wonky, I could do edit.hsb, and it's actually going to bring up a data editor. So if I wanted this to be 0.025, because I happen to know that that's the value for the data, I can put that in there and then exit out. Now let me see if what happens when, yeah, so you can see it didn't save that value, right? It's still 022. So instead, when I have this line of code, it's saying create a new file called HSB edited. That's a function of edits I'm about to do. So if I run this whole line, it's opening that up again. I'm going to just change this to 001 just so everyone can see it. I'm going to close it. And now if I do view HSB edited, right, you can see that value is now 0.00001. So it's created a new file with that edit. So that's just a quick way if you see that there's an issue that it's like, I don't want to have to do all this coding to change the value. It's just this one or two things, you can easily do that. And then if I wanted to actually say, I want to create a new file back in my folder that's called HSB edited, I'm going to say write CSV. So this is saying write a CSV file from the object HSB edited, right? So I created a new data file, a new object, where I edited a value. So it's saying write a new CSV file from the edited file and call it whatever this is right here, which in this case, I'm going to call it HSB adjusted. So when I get that, I now have a new file in my folder called HSB adjusted. So that's just a very quick way to do some data read in. And then next week, we'll go through some of those other pieces and really start digging into some data management stuff. I'm going to stop here. I'm going to stop sharing. Let me stop the recording real quick.